Excellent. Hello, everyone. I'm so glad you came to this talk. My name is Shane Carr. I'm the chair of the ICU4X Technical Committee in the Unicode Consortium, and I'm going to be talking to you about ICU4X 2.0. So first, I'm going to give you a little bit of an intro to ICU4X. So what is ICU4X? ICU4X is an internationalization library. I love this picture. I have it in almost every talk I give. i18n, it's internationalization. It's I followed by 18 letters followed by n. It's one of the longest words in the English language. And what is i18n? Here's two examples of i18n operations. On the left, I just took today's date and I formatted it in various locales and calendars around the world, which you can see written there. Dates look very, very different depending on your language and locale. On the right side, I've got examples of segmentation in Japanese, where you find breakpoints. In languages that have no spaces, it's quite a challenging problem. So these are two challenging problems that you need an internationalization library to solve. And that's where ICU4X fits in. So I'm just going to briefly go over the i18n stack. So on the bottom of the stack, we have Unicode, which provides the foundational algorithms and specification that we build on top of when we build i18n libraries. But on top of Unicode, we've got the CLDR, the Common Locale Data Repository, which has data for hundreds of locales, as well as text for person names and message formatting keyboards and many other things. On top of CLDR, we've got ICU, including ICU4X. This is the code that implements the algorithms that are in Unicode with the data that's in CLDR. So it sort of takes those parts, puts them together, and gives us libraries that do cool things. On top of that, we have the platform API. The platform API is exposed in various different ways. On the web platform, it's exposed in ECMA 402. I'm also the chair of the ECMAS 402 task group for internationalization of the web platform. It's in Android, it's in Mac OS, iOS, it's in many, many different places, the platform API. And then finally, on the top, you have your app. When you write an app that uses internationalization, it often uses it through the platform API, or it could use ICU directly. And those are both valid architectures for writing your app. So this is overall the i18n stack. So we're focusing today on ICU4X, which is that box right there in the middle. So that's where we're sort of looking and focusing on today. So when you're building i18n and building applications, you often have certain challenges that you need to overcome. So I'm going to go over a few of those, and I'm going to show how ICU4X fits in. So the first is the growth of data. This is one of my favorite charts. I also love having this in talks. So this is a three-dimensional graph. On the x-axis, we have the number of locales in CLDR. On the y-axis, we have the coverage level, meaning the number of features in each locale. And on the z-axis, we have the CLDR release number. So for example, you can see that every release, CLDR adds more locales. That's why the x-axis keeps growing, but also CLDR adds more features, which is why the y-axis keeps growing. So we end up with this mountain. And as this data keeps growing, it gets more and more data that internationalization libraries have to deal with. You can see that, maybe 10, 15 years ago, you had a little sliver down there in the corner. Like, you could ship all that data in your internationalization library, no problem. Like, that's fine. But now, in 2024, like this chart keeps getting bigger and bigger, and it's starting to be unwieldy to actually ship all this data in your app all at the same time. So that's one challenge that you have when building a global app with i18n libraries. A second is that because of that same problem, adding languages often has diminishing returns. Like if you add the first 50, 60, 70 languages, like, you'll start getting more clients. But then, like, if you add another 100 languages on top of that, like, you'll gain another 10% of users, but then you also double the size of your app, and then people will stop downloading your app from the rest of the market. So you have diminishing returns, which we would love. We would love to support all the languages, of course. A third is that devices have different requirements. So there's radically different requirements for all of these different types of devices. You've got, like, a smartwatch, which wants to have really low memory, wants to run things on microcontrollers to be very efficient with memory. You've got phones, which are pretty powerful computers at this point, but they're much less powerful than, say, a laptop on the bottom right, which has a lot more compute. It might even have a GPU built in, which is also different requirements than a data center. When you're looking at a data center, you're really looking at scale. Like, how does the memory usage and the CPU usage add up over all of your servers in your data center? So all of these have different requirements. You have new programming languages every year. You can see the evolution of some of these languages over time. Here, when we build i18n, you're often building like in a certain framework, and like you have access to the tools in that framework. So if you're building an application in say Dart, like you're using the i18n tools in that language. If you're building it in Objective-C or in iOS, you're using the things in that language. But as an i18n group, as Unicode, we have to meet you where you are in your language, in your programming language. So that's another challenge with scaling. The last challenge with scaling is that a lot of people say, well, just make an API for this. Just make an API as i18n as a service, right? It's like have like some microservice somewhere that you can like query to like give you all your strings or something, right? This doesn't make sense for i18n because i18n is often right at the surface. It's right when things are rendering. It's usually often run in the compute loop, in the painting loop on your server. You can imagine that if you had to take this block of text and like send it to some server to get the breakpoints, then it would come back like that would really add to the latency of your app. It also has privacy implications if you're sending this data back and forth. So you want to be able to do this stuff on device, right? On device. So the wish list for a scalable i18n library is all of these things. You want to pay for what you use, not for what you don't use. You want to be able to add extra locales on demand. You want to be able to run on all these different types of devices. You want to work in both today's and tomorrow's programming languages, and you want to run everything on device. So this is the wish list that we focused on when we started building ICU4X. So yeah, here's all the different pictures there. So ICU4X is an internationalization library. What does it do? One, it's portable by design, meaning that it's able to run on different platforms, different types of devices, and different programming languages by design. From the get-go, this has been one of the things we've been focusing on. The second thing we focused on is by making it lightweight. So it means we use compile time, deb, code elimination, data slicing, so that you only bring what you use. And it's very modular. And we've really focused on a design to achieve this. And I'll show you a few examples of that later in the presentation. And the third thing is making it secure. We write in Rust, a memory-safe language. There's many clients who are very interested in like, can we make our code base more secure, more bulletproof, and using Rust is a really great way for enterprises to be able to achieve that goal of having a secure i18n library. So these are sort of the three guiding principles for the ICU4X project. So let's go ahead and talk a little bit about our organizational structure. We're the ICU4X Technical Committee in Unicode. We have a participation from several member companies. These are three who've done, a particular large amount of contribution to the project. I work at Google. Then there's also Mozilla and Amazon who've also made major contributions to the project. Okay, so now I'm going to start talking a little bit more about ICU4X, CLDR, and ICU. So one question I get a lot with ICU4X is like, how does this fit in with like ICU4C, ICU4J, CLDR? One thing that we have this year, which we didn't have last year, is we've really built this conformance dashboard. So ICU4C and ICU4J, ICU4X, we're all based on CLDR. That's something that's similar for all of us. We all have the same data. We all aim to implement the same algorithms. But we have different code. So how do we actually demonstrate that like we have the same behavior? If you're using ICU4J today and you're using ICU4X tomorrow, you'd like those to be relatively similar in how they behave. You want them to conform to the CLDR specification. So now we have this new conformance dashboard. So you can go in for many components. You can browse and see exactly what the behavior is in all the different libraries with many different test cases. You can see what's supported and what's not supported. And this is a tool that we now offer you to be able to go and make those judgments and those calls. So next thing we want to talk about are benchmarks. One thing that people ask me a lot is like, well, why should I use ICU4X? It sounds great. Like you have all these cool goals, but like I'm already using ICU4C or ICU4J. Like they seem to work fine for me. I have some of these challenges, like, maybe it's a little bit big or uses too much memory. Can you show me what I actually stands to gain out of maybe considering using ICU4X for my project? So here's some benchmarks. These are brand new benchmarks. I just calculated these this week. ICU4X 1.5 is our previous release. That's the one we released earlier in the year. ICU4X 2.0 is the release that we're working on right now that you'll be able to go home and very soon this quarter be able to use. So these are fresh out the press. IC4C76 is being released tomorrow. So like these are very, very new numbers. So what I did was I made a datetime formatter. So you saw earlier in the slides about like, how do you format a date with this calendar system in this locale, right? So what I did was I created a datetime formatter. I set it up with some locales and some inputs. And I took 100,000 dates and I ran it through the formatter, right? And the outputs are the same between all these different libraries. They all produce the same output. So now we can actually compare what are the performance characteristics here. So ICU4C76 has a performance there. ICU and then ICU4X are all the rest of the columns. Let me talk a little bit about what these different columns are. So the ones that say blob, there's two fundamental ways that we allow ICU4X to access locale data. One is via dynamic data loading. So this is you have a data blob that you load at runtime and then use in your app. We call that postcard or blob data. The other way is by baking the data into your app. So this means that the data is already statically analyzed and available as opposed to being dynamically loaded. We call that baked, right? So these are two different ways that you can load your data in ICU4X. ICU4C doesn't have such a toggle switch, right? So this is just showing some of those data numbers that I just got here. You can see ICU4X baked numbers are quite small compared to ICU4C76. ICU4X 1.5 blob is a little bit higher than I thought it was, but problem solved because ICU4X 2.0 blob is also quite efficient. I can tell you some of the reasons why. Actually, I'll save the reasons why for the slide in a few slides now and actually show you like what changed with datetime format. So the takeaway from this slide is ICU4X is like an order of magnitude faster than ICU4C for datetime format. How about for memory use? What I did was I took that same application, the same application that's looking at your calendar systems and trying to format your dates. And what I did was I measured the memory use over the lifetime of the application. In this loop, the loop that is measured in this graph, which is also brand new, what I did was I created a new datetime formatter for a locale, and then I format a date, and then I throw the formatter away. So this is a create and destroy type of call site. So you can somewhat improve this in ICU4C by caching your formatter in a cache somewhere so that you don't have to create it every time. So just to be completely transparent about what we're measuring here. This is create and destroy of a datetime format. Yeah, this is the memory use. ICU4X, the allocation is I need to allocate a string to save the output result into. That is the allocation. There is absolutely no other allocation that happens, not in 1.5, not in 2.0. They're not in blob, not in baked. The only allocation is I needed to allocate a string to store the result. That's the only allocation. ICU4C has many more allocations than that. And if you would notice, this is a log scale graph. Whether it's a fair comparison, it is a fair comparison because I created and destroyed the formatter in both ICU4C and ICU4X in order to create this graph. But yeah, ICU4X is like 3-4 orders of magnitude less memory than ICU4C. So similar results in ICU4J. Why would you care about this? Maybe if you're in like a data center, for example, and you're running a lot of this thing at scale, like this can really have an impact for you. Binary size. This one is a slightly older graph. This is for a number format, but the graph is still valid and is still true. What I did was I took a number formatter. So this is the thing that takes 1023.50 cents or something like that, and it creates a localized version of that string in a locale. I wrote a program using ICU4C. I wrote a program using ICU4X. Before I wrote the program using ICU4C, I actually made an API proposal to the ICU-TC being like, number format is not as efficient as it could be. Here's this new thing I'm calling simple number format that like does it a little bit more efficiently. I did that before I made this graph. So this graph is using ICU4C simple number format as well as ICU4X. Code size is pretty self-explanatory there. I gave you a few reasons why. It's because ICU4C ships a lot more logic involving its parsing of data, how it handles resource bundles. It ships a lot of more information regarding how it processes locales. how it looks up to the data in the locale bundle, and it also has a lot of legacy standard library code that it also ships in order to do things, even like allocating vectors. The way IC4X avoids this is that it doesn't do any of that. We only ship the code that is absolutely needed for actually achieving the goal of formatting a number without the other things that we don't necessarily need. Let's see, one more graph. This is 1.5 versus 2.0 binary size. So again, 1.5 is like the previous release from like earlier in the year. 2.0 is the new release that's coming out this quarter. This is again, this is a multi-component demo. So this demo covers, I believe, datetime formatting. I believe it also covers number formatting and plural rules. And the biggest change here is the datetime formatting. We see that we get we've significantly reduced even on our benchmark, even on our baseline, which is already a pretty good baseline. We've improved it further with IC4X 2.0 with a lot of the infrastructure work that we've done in order to cut in less than half the size of this multi-component IC4X demo here. And the way we achieve that is by using semantic datetime skeletons, which I'm just about going to talk about on the next slide. I will give a open question here, which we can take questions at the end, but start thinking about like, what other metrics would you like to see? I can gather a lot of metrics, right? Like all it does is that, I just have to sit down on my computer and like punch in some commands. Like I can get lots of metrics. I'm not always sure what the right metrics are to like be compelling for like, you to be like, IC4X is a really good tool for the job. I want to see this metric, that would really, drive home the point for me. If you have other metrics beyond those that I just showed you that would be compelling, I'm bring them up and you can help compute them for you. So now I'm going to start talking about things that are new in IC4X 2.0. So now that you've, the first part of my presentation was sort of like a pitch for like, what is IC4X? What does it bring me? Why should I use it? What are some of the numbers behind that? Not just like lofty claims, but actual concrete numbers. That was the first half of my presentation. So now I'm going to move into the second half, which is sort of, okay, cool. IC4X 2.0 is this, new version that we're releasing of the IC4X library. What are some of the things that it brings me? What are some of the reasons I should consider using IC4X 2.0? And I want to spend a lot of time here talking about semantics, date, and time. So what is semantic skeletons? Semantic datetime skeletons. Semantic datetime skeletons, Mark Davis talked about them a bit in his talk yesterday about the CLD design working group. Why do we want them? We want them for two main reasons. One, because of correctness, because semantic datetime skeletons prevent you from doing incorrect things with datetime formatting. The other reason is because it makes things smaller and faster, and I'm going to show why on the next slide. This is one of the key insights with semantic datetime skeletons, is this idea of field sets. What is a field set? A field set lets you take valid combinations of fields that would show up in a date time string and then put them together. One type of field is a date field, and there's these 7 different ways that are valid to represent a date. A date meaning like a day in time. If you want to identify a day and time, these are the 7 valid ways to do so, with information possibly being elided. For example, the day means like today is the 23rd. The year and month are elided, but it is still the 23rd. If you understand from context, that is a valid way to represent a day. Today is Wednesday, is also a valid way as if you already know the week that you're talking about, for example. So these are the 7 ways to represent a date. Then we have the calendar period. Calendar period refers to another period of time that's not a day, that's bigger than a day. And the distinction here will become important in just a minute. There's month, year, and then year with month. So for example, this is October of 2024, right? That is something that you might want to represent in a date string, but it's not an individual specific day. A third is the time. You want to represent the time. Right now it's 11:09 a.m. So that was an hour and a minute. You might want hour, minute, second. You might also want hour. I will note here that minute and second standalone are not considered valid field sets for datetime formatting. People say, well, this video is like 5 minutes, 30 seconds long. Isn't that a valid datetime format? No, that's actually not a datetime format. That's a duration format. So I just want to point that out here. Then we have the time zone. We're in Pacific Daylight Time right now. That's your time zone. That's another field you can have. And then very importantly is the composite field set. These are the ways that you can compose these things together. This is one of the main reasons why we split date and calendar period, because date makes sense to be combined with time, but calendar period does not make sense to be combined with time. It doesn't make sense to talk about an hour within a month. It does not make sense to talk about an hour within a particular date in a month. So that's why we have date and calendar period split. You can combine date with time. You can combine time and date with time zone to create a composite field set. And what I want to emphasize on this string is this is the comprehensive list. This is it. This is the end of the slide. There's nothing else I'm hiding. And the reason why this is important and this is crucial is that like I can actually count like how many possible field sets there are. And this is why ICU4X 2.0 has been able to achieve a lot of its improvements in the date time formatting, because instead of having to ship basically, you know, like an infinite data in order to support an infinite number of field combinations, we only have to ship the data to support these that you see right here. And that allows us to ship much smaller, much tighter data that deserializes much faster, because instead of deserializing data for every possible combination of datetime fields, you're only deserializing it for the specific field set that you're using. So this really enables us to produce, you know, an extremely efficient datetime formatter. And this is how we do it, because this is the actual the complete list. There are some things that we may be adding to the list. For example, this does not include week of year. That's likely to maybe come in CLDR 47. We wanted to sort of start with this minimal list so we can actually show that this problem works. We can continue to iterate on it from there. But this is the entire CLDR 46 list of field sets. Also with datetime, with semantic skeletons, there's also options, which are separate from the field sets. These configure how these fields are displayed. These are the 6 options that we have available for you. You can control the length, alignment, year style, hour cycle, fractional second digits, and time zone style. One important point here is that the options are chosen based on what the programmer or the developer or the application requirements are. One crucial thing about designing an API like this is that you want to be able to decouple the things that the developer or the application or the UX designer controls versus the things that the translator controls, right? The translator, you know, needs to be able to have the influence about, like, you know, how is a month displayed? It's the developer just says, you know, I want to display a month because I need the month in order to make this thing on my screen have context and make sense. But it's the translator who decides, well, how do I display that month in my calendar system and my locale? So it's very important to keep those two things separate. And that's what these options are. These are all options that are designed to be developer focused or design focused options. Okay, cool. Now I'm going to give you a little bit of a live demo. It's not completely a live demo because it's only a demo of docs. So I'm going to go ahead and switch over to my tab and make sure that I stay on time. I'm not going to spend a whole lot of time on this because I want to make sure I get to everything else that I have planned for you today. But this here is the ICU4X documentation page. I'll zoom in a little bit so you can see it better. Yeah, so this is the ICU4X documentation page. This is like tip of main. This is actually the 2.0 alpha docs, even though it says 1.5 in the corner, it's actually 2.0 alpha docs. So these are the different field sets. You can see these correspond to the ones I just showed you on the previous screen. So we can go ahead and click into one of these. So let's say I want to click into YMD. These are all the different field sets you can choose from. I can go ahead and click into YMD. You can see that when I click into year, month, day, this field set has the options that are associated with the field set. Note it does not include something like fractional second digits because there's no seconds field in a year, month, day. But it does include the ones that are relevant to displaying a year, month, day. So you'll be able to configure and set those up. And then this is what a call site might look like. This is Rust code. Don't be afraid. It's Rust code. It's not that scary. So what you do is you have a datetime formatter, which is the name of the type that we export from the ICU4X crate. And you call try new, which is basically the constructor. Rust calls its constructors try new because if they return like a result, you want to be able to handle the results. So it's called try new. You give in your locale right here. You give your locale, and then you give the field set configuration. In this case, I want a short year month day, and I go ahead and do that. And then the unwrap is basically like, I don't expect that there's going to be an error here. You can abort the application if there's an error. That's what the unwrap will do. Then I can go ahead and create a date. In this case, I'm formatting, this looks like May 17th in the year 2024. And then I can go ahead and see what happens when I call the format function. It'll go ahead and do its job, which is format this date according to locale en with a short year month day. And this is the format, which is the correct format according to CLDR data. Yeah, and I will point out that one other cool thing about ICU4X docs is that every one of these examples is tested in continuous integration. We spend a lot of time on getting our tooling set up for continuous integration in GitHub Actions. So every example that you see here in our docs is tested. Like this is actually a unit test for the library. So like this code works. If you see it on the page, we guarantee that it works because it's tested in our continuous integration. I'm going to go ahead and switch back to the slides and then continue. Yeah, so just a quick technical note about how we achieve this. I'm checking time, looks like I'm okay. Technical note about how we achieve the smaller data. So by having a datetime formatter that's parameterized by the field set, you're not actually getting just like some datetime formatter. You're actually getting a specific type of datetime format, for example, a year, month, day formatter, right? And by having that, it means that the compiler is able to, at compile time, do dead code elimination so that you actually only end up with the pieces you needed for year, month, day formatting. If there's anything that you don't need for hours, maybe you don't need to compute the hour period or day period or something like that, that code is not included because it's not needed for a year, month, day formatter. So that's how we achieve the small code size and small data size that I showed you previously. Also, the smaller data payloads you get from these can be more easily deduplicated. For example, there's many locales that share the hour format, but they might differ in like the date format. By splitting these into different payloads in the data provider under the hood, we're actually able to deduplicate them a lot more efficiently. Okay, now I'm going to give you a little bit more about ICU4X 2.0. Yeah, I'm going to try to keep this section to about 5 minutes so I have time for questions. So first, I just want to, give a shout out to all of the top contributors. I had this slide in my presentation last year. I'll have it again this year. I've updated it with the contributors who have been the most prolific contributors for the last 12 months. Robert sort of wins the race this year. I don't know if he's in the room right now for most commits. He had 396. That's more than one a day. That's a lot of great work that Robert did. I came in second with 319. Eunice, one of our colleagues in Zurich, has 117. Manish has 108. Jose Julian did a lot of work on the plural rules crate, as well as some other work on the datetime and time zone crates and the calendar crate. He had 17 commits. Cartavia, who was a Google Summer of Code contributor, did a lot of work on the datetime formatter, the duration formatter, had 17. Makoto is one of our colleagues at Mozilla. He owns the segmenter component. He's in Tokyo, and he had 14 commits. Henry is another one of our Mozilla colleagues. And he's done a lot of great work on the normalizer and collator components, and he has 11. And that's just the top 8. There's so many more people who've made this project a reality. When I was going through, before I made this talk, I went through all of the commits, close to 1,000 of them in the last year, and I'm just continue to be amazed at all the work that everyone's put into this project. It's really gotten a lot of love from a lot of really talented people who've contributed to all different components in the project. So I already told you about datetime, so I just want to give you a few more highlights for some of the new things we have in 2.0. This is a big list. I'll just go through it quickly. We have several new experimental components. We have a duration formatter. I was talking about that a little bit earlier. Cartavia, our Google Summer of Code contributor, contributed the duration formatter. We have a new unit formatter and a currency formatter. We also have experimental person names and a unit converter. available in the experimental component. When I say experimental, it means that the feature works, but it might not have all of the features that we want in order to sort of consider it to be graduated. So like you can use experimental components, it's sort of like draft. ICU4J calls it like a draft. We call it experimental. We graduated the case map component. That was experimental last year. Now it's stable. Manish did a lot of great work on the case map component. We have an all-new Diplomat WASM demo. There's a whole talk after mine. Tyler, one of our other Google Summer of Code contributors, did a lot of great work, and we have a new Diplomat WASM demo that he'll be showing you more about in the next session, so I won't steal his thunder. We have a new locale data parameter on the world sentence segmenter. This was sort of a bug that had been sitting around for a long time in order for full ECMAScript compliance. We want to be able to have the locale parameter so we can do things like sentence break suppressions. We support Unicode 15.1 as well as 16 in our segmenters. We have a new plural elements, which is a new API around how you do plurals selection. Robert did a lot of work on this, on the plural elements API. We have IXDTF parsing. IXDTF is like an ISO string that has like year, month, day components inside of it, and you want to be able to parse out like an IXDTF string into a structured calendar or time zone object. So we now support IXDTF parsing and time zone end-to-end display names. I could have a whole talk about how we do time zones because it's really, it's quite a heavy, big, complicated topic, but I'll just summarize it to be that we've done a lot of work on the end-to-end time zone display name algorithm, and we've done a lot of work to also decouple ICU4X from the TZDB, which is also another thing we were able to do to sort of achieve like a smaller binary size by basically taking the TZDB part of time zone display names and the rendering part and sort of make those two different components. Infrastructure upgrades. So that was like feature upgrades, infrastructure upgrades. This was like internal stuff under the hood. There's a lot of work we did here. We revamped the data request architecture with locales and attributes. This is one way that we've been able to create, we needed to do this in order to have the fine-grained slicing that I was able to show you in the datetime formatter. So that was a really big effort earlier in the year. All string input functions robustly handle ill-formed UTF-8. This is really important for FFI because like in C++, strings are not guaranteed to be valid UTF-8. So we're able to robustly handle that without like having undefined behavior. Improvements to the ICU4X data gen, because again, a big part of ICU4X is you can build your own data files, your own data bundles. We've done a lot of improvements there, such as adding locale families. Dry data provider, so you can do a data lookup without actually having to load the data. This does things like it allows you to have a supported locale query. We have script fallback priority, which has allowed us to improve the behavior and the performance and the data size of the collator component. We have borrowed variants of the normalizing collator structs. Henry Sivinen from Mozilla did a lot of work on this. It means that you can create a normalizer and a collator without having to actually load data, which is kind of cool. Underlying zero-vec data format optimized. So all of our data in ICU4X is backed by this thing we call a zero-vec, which is sort of like a zero copy vector of data. We call it zero-vec. So we did a lot of work on the zero-vec data format. Manish did a lot of work on that area. Improvements in the non-Gregorian calendrical calculations. I did some work there earlier in the year in order to improve the performance and efficiency of non-Gregorian calendar calculations. Zero try is a data structure that I've been working on. It's a zero copy try that we use because it's really efficient at storing strings. And as you can imagine, there's a lot of strings in i18n applications. So we use that in more places, and that's been able to give us more efficiency. And fine-grained error enum, so you can really fine-tune how you handle errors. You can, when you write application, you can really think about these different error cases and how you handle them with fine-grained error types. That was a big mouthful. One more slide here. FFI improvements. Manish has really been leading the charge on the Diplomat, which is the tool that we use for bringing ICU4X into other programming languages like C++, JavaScript, Dart, Kotlin, soon, TypeScript. We have more usage of idiomatic features in those languages like getters, setters, constructors, stringifiers, and we follow more idiomatic per-language naming conventions and namespacing, which is a really big one. We didn't have namespacing in ICU4X 1.0, ICU4X 2.0, we have namespacing. So many people might asking, what's the status of ICU4X 2.0? Like, Can I go use it right now? Well, the answer is kind of, because we have something that we would call, I would right now call alpha quality. It's feature complete, asterisk, ask me later. But it has like the datetime component and all those other experimental components I showed you. Pretty soon we should be able to ship our beta. That, like, when I say soon, I mean in a couple of weeks, which will after we've done the full API review with Marcus among others. And then to do in final, we'll finish the FFI layer and small function renames, as well as some other things that we would like to do. Nice to have if we have time. ICU4X ships when things are ready. We do always ship a CLDR release, but we don't have a regular cadence like the ICU project does at this point, because we're still a very fast-moving project. So we sort of release when things are ready. But we always release the CLDR releases. When CLDR makes a release, we always make a release too. Yeah. So I just want to point out, it's it's 4+ years we've been working on this. It's truly exceptional engineering that has brought ICU4X from a concept that I pitched to my leadership team 4.5 years ago to actually be a reality, where I can show you these really cool graphs that, like, I knew like we could create these graphs, and now it's like, yeah, I can go create these graphs. We've gotten a lot of support from Google, from Unicode, to really bring this to make a reality. So yeah, this is my last slide. Plans for 2025. We had a summit on Monday where we sort of planned out our OKR, our team OKRs for 2025. We're going to be focusing a lot on closer compatibility with IC4C, IC4J, because people who have applications that ship IC4C, IC4J might want to use IC4X a little bit, but maybe not migrate the whole thing. How can you do that without like duplicating data in code? We're going to be looking a lot at that in 2025. Also, organizationally, seeing how we can reduce work between the IC4C, IC4J, and IC4X TCs on the Unicode side. Maybe some structural things there. ECMA 402 coverage, which is one of our big clients. That's what is used in Chrome and Firefox and Safari. Trying to get to close to 100% there, so that we can unlock those clients so they can adopt IC4X, as well as continuing to focus on third-party adoption. If there's anything I'm missing from this list, please come up and tell me. We can get it into our OKRs now. You're our clients, you're our customers in this room. So we're building this thing, and we want you to use it. So if there's something that's not on this list that's like, well, I will use IC4X if you don't do this thing, please come up and talk to me. That's my last slide. This is my call to action slide. I have a couple of QR codes. On the top right is our low traffic mailing list. I think that gets an email every time we have a release. You can go sign up to that. On the bottom right is my Mastodon, which you can follow me. I also give you some more links you can find. I think I have time for a few questions. I know I went through those slides really fast because I have so much content and I only have 40 minutes. So I apologize if I went through that too fast, but if you have questions, I think I have time for a few questions. I think Manish and Joel would be my mic runners.
Why 2.0 rather than 1.6?
The question was why 2.0 instead of 1.6? That's a good question. The answer is we follow semantic versioning. All of our releases previously have been, adding new features, but in order to really achieve the gains we made in datetime formatter, we actually had to remove old APIs that were in 1.5. And removing APIs is not a thing that you can do in a dot release. So we make a full release. This is a different policy than IC4C has. IC4C is like, if there's an API, it'll never ever get deleted. ICU4X, we have a slightly different policy, which is like we almost never delete things except once every few years we'll have a major release. This is our first major release since 1.0. I think 3.0 might be coming in like 2 or 3 more years. So we are stable, but we also give ourselves a little bit more room to actually evolve and really deliver these numbers that our clients care about. Maybe time for 1 or 2 more questions.
Yeah. So you were mentioning the semantic datetime formats and how there are 46 combinations. I'm assuming there's short, medium, long in addition to those, so multiply by 3, I guess. So what's the actual saving compared to the unbounded space that we have in, say, ICU4C?
I think I had a graph for that. This is the closest I have for a graph for that. So this is a multi-component demo, but the biggest part of the demo is the datetime. So previously in ICU4X 1.5, which was the old datetime, we had to ship all lengths, all patterns, for fields, even if the fields weren't being used in your datetime format. Or in ICU4X 2.0, we only ship the ones you're using. So this is the scale, this is the order of magnitude of the improvement we get by shipping the field set approach.
Oh, I had a question. First of all, okay, Aniket here. I work with Coupa. Kudos to the team for implementing this. Really well done. I understand that ICU4X is meant to be write once and like adopt everywhere. So on that note, I work on Ruby on Rails stack, and I was wondering, in your documentation, do you show how this can be applied or adopted onto different technology stacks, especially, let's say, like for an interpreted language like Ruby? How do you do that through Diplomat?
Oh, yeah, that's a good question. We have tutorials on our website about, for the languages that we support, how you would be able to integrate ICU4X into those languages. We have a tutorial for JavaScript, for TypeScript, and for, I think we have one for Dart now. We have definitely one for C++. Ruby is not a language that a contributor has come and we've really focused on. It's absolutely something we could support. If you or someone at your company or someone else in the room is like, I wanted to get this in Ruby on Rails. I love Ruby. It was one of the first programming languages I learned. I would love to see ICU4X in Ruby. That's a really good idea. That's not one of the ones we currently have in Diplomat, but the bar to actually get it into Diplomat and into ICU4X is much, much lower because we already have a very well-lit path. For example, there was a third-party contributor who just added a Kotlin backend, and Kotlin is quite a complicated one because it also has to deal with the JVM. And now we're really close to basically being able to ship ICU4X in Kotlin, which is really exciting. So this is definitely something that an engineer could sit down and really work on, and we have great support and great colleagues who will help assist with that. I think there's time for maybe one question.
And stick around for Tyler's talk next if you want to learn more about how to do things in Diplomat.
I think I saw Alexia and Mark both raise their hand.
I have a quick question. Hi, I'm Alexei. I work for Meta. Are those benchmarks consider use of FFI? Like basically, if I use ICU4C in C++ and ICU4X in C++, do I need to go through FFI, and will I see different benchmarks?
The FFI, that's a great question. The FFI is generally designed to give you the same types of numbers. However, there's some things we can do in Rust that require a little bit more work in FFI. So for example, the full, let's see, I think it was on one of these slides, this thing. Being able to parameterize a datetime formatter is not something we support in FFI, but we would be able to export, and we plan to export the most common high roller cases here. So that if you wanted to get the optimized ICU4X 2.0 year, month, day formatter, that would just be a type we would export on FFI, and then you would get the same types of benefits. One other thing about FFI is that FFI also owns the stack space of these objects, and the stack space has also been cut down from about 5K to about 500 bytes. So you will see also benefit on the FFI side. And Mark, you have the last word.
Oh, last word. Very nice.
Last question.
The question is, if I have a different programming language and I work through and I want to add the FFI support for that programming language, how many engineer days do you think it would take?
I'm going to defer that question for Tyler's presentation because Tyler is going to be talking about Diplomat, which is our tool for bringing this to other programming languages.
But I can't be there, so maybe you can tell me offline.
Around 10 engineer. It's around 10 engineer minutes if you're familiar with the project, and maybe 30 if you're not. It's very easy.
Okay, I'll be around the rest of the day. If you have more questions, thank you so much for listening.